Hi students and friends, welcome to the channel Learn and Teach by Ayaz. I'm continuing my video lessons for the topic moles. The learning outcomes for this video lesson is to state that the mole is the unit of amount of substance and that 1 mole contains 6.02 into 10 raised to the power 23 particles. For example, atoms, ions, molecules. This number is the Avogadro constant. Use the relationship amount of substance mole is equal to mass divided by molar mass in gram per mole to calculate an amount of substance, mass, molar mass, relative atomic mass or relative molecular formula mass, number of particles using the value of the Avogadro constant. Let's start with the concept of moles. In terms of particles, you define mole as the amount of substance which contains Avogadro's number of particles. That number of particles is 6.02 into 10 to the power 23 particles. Remember, we are talking about 1 mole of any substance. For example, if you have 1 mole of sodium, it must contain this number of particles. This is Avogadro number, 6.02 into 10 raised to power 23. When you say 1 mole of oxygen gas, again you have same number of particles, 6.02 into 10 raised to power 23 particles. But when you say 1 mole of water, then again they assume that the number of particles will be 6.02 into 10 raised to power 23. The symbol for sodium is Na, and sodium is a metal. We know that. So in metals, we have discrete atoms of the metal. So in case of particles for sodium, you are also allowed to write atoms for particles. You know the formula of oxygen gas. The formula of oxygen gas is O2. It's a non-metal and it exists in the diatomic state. That's why I'm writing O2. So for particles, you are allowed to write molecules of oxygen gas. Similarly, the formula of water is H2O and it also contains molecules of water. So you are again allowed to write molecules for particles. In terms of mass, 1 mole of a substance is its AR or MR expressed in grams. When it is 1 mole of atoms, then it will be its AR in grams. In previous slide, I've talked about sodium, and sodium is a metal. It contains discrete atoms of sodium. Make it atoms of sodium if this term confuses you. So when I say 1 mole of sodium, then I have to look for the AR of sodium. AR of sodium is 23. This is sodium and the AR of sodium is 23. So we'll consider this as 1 mole of sodium has a mass of 23 grams. In the same way, you can work out the or express the AR of other metals in grams. For example, if I will say 1 mole of aluminium, we have aluminium here, AR of aluminium is 27. So then I will say that 27 of aluminium will be considered as 27 grams. 1 mole of aluminium. Al is a symbol, has a mass of 27 grams. We have other examples. We have copper. 1 mole of copper has a mass of dash grams. So in dash, I'm going to write the AR of copper. AR of copper is 64. Here we have copper, it's 64. So the AR of copper will be expressed in grams. So you write 64 here. 64 grams. 1 mole of copper has a mass of 64 grams. Similarly, you can write the mass of inert gas like helium in grams. 1 mole of inert gas like helium has a mass of dash grams. AR of helium is 4, so you will write 4 grams. In terms of mass, 1 mole of a substance, it is AR or MR expressed in grams. When it is 1 mole of molecules, then it will be its MR. Now this time you have MR. MR means relative molecular mass. AR is the relative atomic mass. So MR will be relative molecular mass. So remember, molecules can be of either elements or compounds. For example, we have 1 mole of oxygen gas has a mass of dash grams. So oxygen, first of all, I will look at the AR of oxygen. Where is oxygen? It's in group 6. This is group 6. This is oxygen. AR of oxygen is 16. So we have AR of O is 16. And we know that oxygen exists in O2 state. So we'll write MR of oxygen. MR of O2. So you have to multiply 2 by 16. And we will get 32. So 1 mole of oxygen gas has a mass of 32 grams. Remember, it's not 16 grams. It is 32 grams. Some examples. 1 mole of chlorine gas has a mass of dash grams. You should know the formula of chlorine gas. Chlorine is in group 7. And let me show you group 7 elements first. This is group 7. We have fluorine, chlorine, bromine, iodine, and astatine. They all exist in diatomic state. Diatomic state means F2, Cl2, Br2, I2, At2. So for chlorine, you have to write the formula Cl2, not Cl. Write Cl2 for chlorine. Now you have to write the mass of chlorine in grams. You will work out by yourself. Look at the AR of chlorine, then multiply it by 2. AR of Cl multiply by 2. Then we'll get the answer. 1 mole of water has a mass of dash grams. What is the formula of water? The formula of water is H2O. So what you have to do? Work out the MR of H2O. MR of H2O. Then this will be expressed in grams. You will write it here. You'll do this by yourself. For your convenience, I am only doing the last one, which is about methane. The 1 mole of methane gas has a mass of dash grams. The formula of methane is CH4, MR of CH4. Let's work out the MR of CH4. We have one atom of C, so you'll multiply AR of C by 1. We have 4 atoms of hydrogen, so you'll multiply 4 by AR of hydrogen. What about C? AR of C. C is the symbol for carbon. It's in group 4, and here will be the AR of carbon. What about hydrogen? Here we have hydrogen. AR of hydrogen is 1. So for chlorine, I'm writing 1 multiplied by 12. 1 multiplied by 12, we will get 12. What about hydrogen? 4 multiplied by 1, you will get 4. So we will add up 12 in 4 and we will get 16. So 1 mole of methane gas has a mass of 16 grams. Use the relationship. Now this time you have to use this relationship. Amount of substance in moles. You have to divide the mass divided by molar mass. In order to get the mass, you have to divide the mass by the molar mass of that molecule. In case of atom, you have atomic mass. Let's do some examples. For sodium, if mass is 46, what will be the moles? So first of all, you have to calculate or work out the AR of sodium. AR of Na is 23, which means in order to find the moles of sodium, you have to divide the mass by the AR. 46 divided by 23, and we will get 2. So 2 moles of sodium. Now let's work out the moles for a gas like oxygen. Calculate moles of oxygen gas in 16 grams. We know that oxygen exists in the diatomic state. O2 is the formula. So first of all, you have to work out the MR of oxygen. MR means relative molecular mass. MR of O is equal to 2 multiplied by AR of oxygen. AR of oxygen is 16. So we will get 32. So what we will do, in order to find the moles of O2, you will divide the mass by the MR. 16 by 32. It will become 1 by 2 or 0.5 moles. We have 0.5 moles of oxygen. Some work. Calculate the mass in 2 moles of lithium. Now I want to find the mass of lithium in 2 moles of lithium. 1 mole of Li has a mass of, I have to write the AR of lithium. Look at the periodic table. AR of lithium is 7. Here we have lithium. This is the AR. 7 is the AR of lithium. So I will write 7 here. Therefore, 2 moles of lithium has a mass of X. Do the cross. You get X is equal to 7 multiplied by 2. what you'll get? You'll get 14 grams. So in 2 moles of lithium, it contains 14 grams. Can you work out the mass in 1.5 moles of water? Repeat the same procedure. First of all, you write 1 mole of water, which is H2O, has a mass of, you simply work out the MR of H2O. What is the MR of H2O? We have 2 atoms of hydrogen and AR of hydrogen is 1. So I will multiply 2 by 1. Plus, we have 1 atom of oxygen. I will multiply 1 by AR of oxygen. AR of oxygen is 16. This is 16. So I will write 1 multiplied by 16. If you will add up this, you will get 18. So 1 mole of water has a mass of 18 grams. Therefore, 1.5 moles of water has a mass of X grams. Do the cross. X multiplied by 1 is equal to 1.5 multiplied by 18. .5 multiplied by 18, you'll get 27. 27 grams will be the final answer. Calculate the moles in 46 grams of sodium. Now I want to calculate the moles in 46 grams of sodium. You have 2 ways to solve this. Either use this formula, moles is equal to mass by AR or MR, or develop a relationship like the one I have performed here. I will do this for you. You should know the AR of sodium. AR of sodium. AR of sodium is 23. You will find it out by looking at the sodium in the periodic table. Here we have sodium. So AR of sodium is 23. So you will write 23 grams. Don't write only 23. 23 grams of sodium in 1 mole. Therefore, 46 grams of sodium in X mole. So we'll get 23 into X is equal to 1 multiplied by 46, or X is equal to 46 divided by 23. We will get 2 moles. Do this by yourself. 50 grams of calcium carbonate. The formula for calcium carbonate is CaCO3. Now using the relationship, amount of substance mass by molar mass by moles. We have last question. Calculate the molar mass when 1.5 moles of X has a mass of 18 grams, Hence, identify the element and name it. We don't know the element. So what you will do, you will write 1.5 moles has a mass of 18 grams. Therefore, 1 mole has a mass of x grams. Do the cross, we will get this 1.5 x is equal to 1 multiplied by 18, or x is equal to 18 divided by 1.5. 18 divided by 1.5, 12. 12 is the mass for 1 mole of this element. Which element has a 12 as its AR? 12 is the AR of element. By looking at the periodic table, you can easily deduce the identity of the element. If you look at the periodic table, only carbon is the element which has 12 is its AR. So, identity of the element will be carbon. Thanks for watching. Press like, give comments and share my video. For more videos, subscribe my channel and press the bell.